Hello, everyone. Good afternoon. My name is Chris Kalima. I'm the VP of Product Management at Intertrust. And I'm here today to talk about Agile data operations, how to optimize and innovate for renewables. I'm going to go ahead and share my screen here. One moment. Okay, let's begin. So first, a bit of background. Who is Intertrust? Intertrust is not an energy company. We're actually a software company. We're founded in 1990. We are headquartered in Silicon Valley. We have offices in North America, Europe, and Asia. We're privately held. Some of our shareholders include the World Innovation Lab, which is a conglomerate of different Japanese stakeholders, Sony, E.ON, the energy company, Origin Energy, and some others. Our expertise is in security, privacy, and trust for open networks and service-enabled devices. We've developed some key technology in trusted distributed computing, digital rights management, and secure interoperability. So Intertrust really was one of the innovators and pioneers in digital rights management. And as you can tell from some of our stakeholders there, Sony and some of the members of World Innovation Lab, we've done a lot of work securing media in the media space, securing digital content as it's being streamed from studios down to actual consumers. So protecting that content as it's traversing through the distribution chain. We do perform a lot of R&D activity. We have a top research lab with a bunch of top scientists. We do have a Turing Prize recipient on our staff. We're active in, as I said, the media space, but we're also moving into other data-driven domains like energy, IoT, automotive, consumer electronics, and healthcare. And we do have 3 divisions within the company. We have a media solutions team, secure systems team, and the data platforms team, which I'm a member of. And again, we're based across the world, extensive track record in DRM, energy, and security. So today I'm just going to start with a bit of an overview about data operations, some of the background, how we view that actual methodology, and then present some of the things we're working on around the data platform at Intertrust, how we're helping organizations with their data operations in renewables, in energy, and then present a use case with RWE. So data operations, if you're not familiar with the term, it's actually derived and inspired from DevOps in software and Agile methodologies. So continuous improvement, being able to rapidly iterate, develop new software products. When you apply that to the actual operation of data and looking at data products, whether it be predictive analytics or some type of machine learning or applications that are data driven, the same set of, or I guess that same structure and framework of different processes and technologies coming together are really the root and combination that compose data operations. So on the top, you have these different data processes. You have development, this continuous integration, maybe of machine learning models, predictive analytics, reporting, different tools and software. You then need to deploy this into a continuous deployment environment. So you're always being able to update production with the latest releases. It may require some orchestration to synchronize the workflow and some scheduling, and then obviously some testing to monitor the ongoing processes, what type of metrics, monitoring alerts are ongoing. So that's, code repositories, agile techniques, the notion of a sprint, being able to get feedback quickly, incorporate that back into the development cycle, and then produce a new version of that product. On the technology side, we have data capture. So that's things like batch jobs, actually getting data from its sources, ETL work at data integration, so data unification, profiling, some types of security are applied there. You may need to transform data to make it consistent and contextual with other data sets, and then preparing that data for consumption. So data catalogs, data lineage, being able to understand where data is flowing from, where it's going to. An important concept here is data governance. This is something that Intertrust is very concerned with, and some of our one of the focuses of our solution, the data platform, being able to provide secure access to these data sets so that only the privileged users of this data can actually access that data. So that also includes collaboration, working not only with different internal stakeholders, but also potentially external service providers or vendors, and then ultimately providing the tools and capabilities to incorporate data analytics, produce reports, create models, integrate with business intelligence tools to really inform and provide value for different business users. And so if we look at this pipeline, this data operations process, there's a number of different data friction points that really inhibit the rapid delivery of these innovations and improvements, which can be delivered through a successful data operations methodology. The first that we see is this misaligned strategy. So a lot of times there's a lot of different operating groups and they may be unwilling to cooperate with one another. There may be some legacy operational systems and processes that are difficult to overcome. There can be ownership bias where one team is reluctant to give up their technology or their solution in favor of a broader solution that might service the entire organization. So we see this in renewables, for example. You have an operations team, but maybe you have other members of the organization, some people who are more concerned with retail or the actual trading of energy. So there's different units beyond just the operation and maintenance. And how do those units align? How do you actually provide data horizontally across the organization? There may be different strategies, different systems. The second topic here is legal risk. So we do see this evolving legal landscape where data ownership and data usage and consent of actual customers or users to use that data is becoming more and more prevalent. So GDPR, obviously in the EU, in California, we now have the CCPA. So this legislation is evolving, it's emerging, and there are different penalties that are involved for actually violating some of these legal constraints. And so that's a legal risk and could be potentially a financial risk, depending on how you're tracking consent to use data, how data is being processed, and what is the lineage of that. Supply chain risks is another concern that we see. So sharing data with partners and vendors that can provide business value. These could be artificial intelligence companies, machine learning companies, companies that are hungry and want to use data and can actually produce algorithms that may improve performance or create incremental gains. But in order to do that, a lot of these machine learning models are very data hungry. They require large volumes of data. You need to actually produce potentially like the lifetime of an asset, years worth of data. What happens when you hand that data over to a vendor or a service provider? They now have a copy of that data, and you may have a contractual agreement in place, but technically they have a copy of that data. You've lost control of it, and there's supply chain risk there. Data usability is a big issue that's always raised. Data is difficult to discover. You don't know the data provenance. You can't locate data. It may have different schemas, different taxonomies across the organization. Data quality might be poor or just unknown. And a lot of this requires ETL jobs that duplicate or migrate data, which not only introduces additional cost, but it also introduces another piece of the pipeline that needs to be managed. So now you've created this ETL workflow, and you need engineers, you need DevOps, you need people to actually ensure that that's operating properly. And then finally, we have these technical barriers. So just data being difficult to access due to different technical considerations. What we're seeing now is a big mixture in both on-prem and cloud-based deployments. So these hybrid type architectures or even multi-cloud architectures. So data is not residing in a single location. Part of it could be on Azure, part of it could be in AWS. How do you get access to that data? If data is stored in different databases, what are the interfaces like to make sure that you can combine that data and make it useful? So these are examples of these technical barriers that introduce friction. So the Intertrust Platform and where we come at it and what we think is important is we've brought together a suite of key technologies to help streamline these data operations. So we provide a time series database that's been specifically built for managing a cost-efficient and scalable compressed time series database, so time event data, low latency access to critical data, as well as a cost-effective storage for lower priority data. So hot data and cold data can be accessed using the same interfaces. And it's a nice data capture for IoT events. If you have any type of logs, anything that's time-stamped, it's really optimized to provide storage and archival in a performant and cost-effective manner. The second is data virtualization. So the platform allows you to go out and connect to these different data stores wherever they may reside. So this could be data lakes, it could be data warehouses, it could be individual relational databases, it could be object stores that you're storing CSV files or Parquet files on. The platform allows us to go out and actually connect to these and provide access to them using Spark, JDBC, and REST APIs that are provided by the service. So that eliminates the need to centralize all your data. It's not a prerequisite to starting to work with that data. You can, of course, if you have needs in data warehouse and you need to actually centralize some of this data, that's perfectly fine. We treat those data warehouses just like another data source. So we can go out and connect to those as well. Data governance. So being able to then govern access to all this data that's located across the cloud, on-prem, in different databases. And so we allow you to provide row and column-based restrictions, these policies that can limit the access that people have to data. There's really two ways in our platform that you can actually compose and distribute access to data. One is by creating data sets that are their own, tailored to the needs of the actual data consumers. So the data scientists, the business analysts, the performance analysts. You can create data sets that are contain only the data they need, or you can impose these restrictions on the access grant to limit which rows and columns those users have access to. So you can restrict access to PII data. You can place row restrictions, maybe based on a manufacturer ID. There's a lot of interesting ways that you can actually use those policies to govern that data. Secure execution. This is a component I think is pretty unique for the platform. It allows you to deploy these algorithms, workloads, and services as Dockerized containers into isolated execution environments where you can control the network egress, both inbound and outbound. And you can also, it's multi-tenancy, so you can dedicate specific resources to these workloads. So each of them is operating in an isolated cluster. And this allows you to collaborate with these third parties without actually exposing your data or your intellectual property. And so for that strategic risk of actually interacting with these different customers, this allows you to let them work with this data, run these algorithms and these workloads without the data actually egressing off of the platform. That's a really powerful feature that provides this interoperability and the ability to engage with these third-party vendors. And then finally, keeping track of everything that happens on the platform, these audit reports. So all actions within the platform are recorded as these immutable audit records. This includes privilege grants. It includes data access requests, these workload deployments in the secure execution environment. So security auditors can go in and review and report on activity as needed for either regulation or compliance needs. And so touching on the benefits for the business, what does this provide, right? When you remove these data friction points, there's a number of areas that we see a lot of gains. The first is in the just overall agility. So this platform itself is much more self-service. It allows data consumers to facilitate the development and deployment of models and applications on their own. They don't need to reach out to IT to ask for a new deployment resource. They can find data in the data catalog. As long as they have access to it, they can begin working with it. So it really improves the agility of an organization to start working with that data, creating these new workloads, models, applications, and different decision-making tools. The second is security, because all of this is being routed through a uniform data platform. All the data access and governance across all of the data assets within the organization can be governed and audited within the platform. So you're not going out and granting individual IAM roles within AWS. You don't have a database administrator that's creating Amy, who's the analyst, her own account to the SQL database. All of this is actually routed through the platform. It centralizes that governance and provides a nice level of security where you can actually keep track and manage everything in one place. Cost reduction is another benefit. So just overall improvements in operational efficiency. This reduces the deployment time, eliminates this redundant infrastructure and data storage. People aren't creating their own copies of data, storing them somewhere else. You're not duplicating execution resources. So all of that leads to reductions in cost. Increased productivity. The stakeholders throughout the data pipeline are now empowered to focus on their core competencies. Data scientists can focus on developing their models and their algorithms. They don't need to worry about the data cleansing. You can let the data managers, maybe data engineers, data stewards, focus on that piece of the pipeline, routing data, creating those ETL workflows, be actually cleansing that data. All of that is handled separately, and it really allows these stakeholders to focus on what they're good at. And then finally, once you've eliminated all this data friction and enable a secure methodology for actually interoperability with, with the data, you can create the environment for innovation. You can allow people to move much quicker with the data, look and iterate on new business opportunities, collaborate with partners, and produce these data-driven innovations. And so I want to jump now into this RWE Offshore Renewables case study. So we worked with RWE at their offshore wind farm in the UK, Windpower. I believe there's 160 turbines there. And we partnered with them to use the platform to develop PowerBoard, which is an application that we built on top of the platform. So that's another nice bit about the Intertrust platform. It allows a lot of development, application development on top of it when it handles that all of the data routing and data operations layer. Now you can develop these tools on top of it. And so that's what we did. We worked with their members of their team in the control room and built an application that blends and analyzes and visualizes real-time operational data that's coming in from the wind farm. And so some of the challenges here, and they're very similar to what we've seen in just that the data friction points. They had a very fragmented data architecture. They had a broad range of independent systems, each of them with their own data stores. So we had real-time SCADA data coming off of the wind turbines. We had connection points with the grid. So we had high voltage substations. They had their own high voltage SCADA systems. We had weather data that was coming in. So not only wind and wave data, but also, met mast that were deployed in the field, as well as weather forecasts. What else? We had works management data. So just tracking work orders and what type of activity was taking place in the field. They're also tracking vessels and tracking technicians as they move about the field using these RFID cards. So all of those systems, independent, deployed for their own specific purpose, but obviously all of that data, having access to it as a whole, was very important. And so as a result of all of this data architecture, fragmented data architecture, we have this diverse set of data types. So you have streaming IoT data, we have event logs, we had relational databases that had, work order records, and again, time series data for production forecasts and weather observations. They didn't really have a data governance model that was in place to actually provide access to all of these different stakeholders that needed it. So you had people in the control room that were looking at it as more of a real-time basis, but then you also have site managers, country managers who want to see actual reporting. So they're much more interested in the aggregate, how did this park perform on a daily basis? And then there are other stakeholders like performance analysts that are looking for the lifetime of the history of the asset, or looking to run these models on an ongoing basis as new data is coming in. There's just a lot of different members that needed access to it, and they didn't have a good way of managing that and governing that. And yeah, so the data usability issues were created there for all of these different key business requirements: real-time access for operations, reports for management, and asset lifetime for performance analysts, as well as potentially partners and service providers that they wanted to engage with that may have limited access to a subset of this data. So this is just a quick photo of the actual control room. As you can see, these are actually dedicated physical systems. They had multi-screen setups here. Each of them was running on its own system, and control room operators were actually physically moving about the room to go to one system to another to sort of check in. So the high voltage had its own system. They have a Siemens SCADA that's managing the wind turbines. They had a technician in the corner that was looking at the vessel management. All of it was not like literally physically displaced around the control room. And so the project goals here, we wanted to enable the data consumers throughout the organization to discover and use this data more efficiently. We want to create a flexible data environment that could easily be adapted to new data sources and tools. So if they went out and went with a new vendor, or brought in a new wind park with new wind turbines, for example, or they switched their weather forecast or production forecast, or even on the consumption side, somebody wants to work in Python, somebody wants to work in Tableau, the ability to plug and play with all of those different upstream and downstream tooling was very important. We wanted to create this central point of governance for managing this data access for all of the stakeholders, including these third-party vendors. we needed to satisfy the security requirements of both the organization and the industry. And we want to ensure that this environment could adapt and scale to meet their future AI and machine learning requirements. One of the things that we saw there at this wind farm, and particularly within RWE, is as maintenance contracts are expiring, some of these organizations are considering taking on this maintenance on their own. So now there's a much more interest and need in predictive analytics. Things that the OEMs were handling previously now may become part of the actual O&M domain. So they may want to bring some of that on board themselves. So making sure that the platform can support that decision if they choose to go that way. And then just overall improve the operational decision making and performance management. And so what we did, we took their platform, we integrated all of these different operational systems. So the turbine and high voltage SCADA, works management, power production forecasts, this technician location, third-party weather data. We developed and deployed this PowerBoard application on top of the platform. So we created this dashboard for real-time monitoring of O&M activities. We had reporting, we have KPIs that are getting computed by the platform, and this is now accessible from any web browser or mobile device. Previously, managers or people who are interested in the operations had to physically call in and talk to someone in the control room. Now they have access on the web. We enable this governed consumption of data because underlying all of this application that we built is the platform. So you have the ability to delegate access to different stakeholders. So performance analysts now have access to this catalog of data that has been incorporated onto the platform. Application developers can work and build their own applications on top of it. And we were able to also deploy these performance and anomaly detection models within the platform's secure execution environment. So we're able to run these against ongoing live data within these Dockerized containers. And so this is just a quick architectural overview of how things were sort of routed together. So we have these data bases on the left-hand side, right? These are our data sources. Then in our PowerBoard application, we do some data transformation. We provided APIs. These fed a web app where these PowerBoard users could authenticate and view different screens depending on their permissions and privileges. And then within the Intertrust platform, we're capturing data in our time series database. We're using this data virtualization component to create subsets of data here, this offshore turbines, personnel. And then underneath the secure execution environment in orange, we're able to run these workloads and also provide an interactive environment where data scientists can connect and actually work within one of these clusters in things like a Jupyter notebook to perform some data discovery. And then finally, on the right-hand side, using those interfaces that the platform provides, the JDBC, REST APIs, analysts can connect their BI tools like Tableau and start to work on producing reports or dashboards or whatever they want to see from their analysis point of view. And this is just a quick couple of screenshots of the PowerBoard application. So you can see here some of this analytical capabilities, this models running, some of these detections, as well as this KPI and reporting. And to summarize, it's been a big success. What we've been able to deliver on those goals of the project. And RWE is looking to now expand as they've merged with E.ON. Now they're acquiring some new offshore wind farms, and PowerBoard and the Intertrust platform is a part of their software that they're looking to roll out and incorporate. And again, now expanding that and bringing this data onto the platform. So now not only just these 1 or 2 or 3 parks in the UK, now they're looking to expand it across their fleet and start to use and leverage some of this technology as they grow their data operations. So at the end of the deck here, a few additional links and resources. If you want to learn more about the Intertrust platform, you can visit our site, intertrust.com. There's a section on there about Intertrust energy data operations that's tailored towards the renewables industry and utilities and energy applications of our platform. And we also have a case study that goes into more detail on the RWE Renewables use case that I just presented this morning. So thank you, and be open to taking any questions.
All right, thanks a lot, Chris. And my name is Patrick. Sorry I didn't properly introduce you in the very beginning. I was running a little bit late from the previous session, but you started off and handled things really well. So thank you very much for the presentation. If anybody has any questions, now's the time to write it in the discuss or the Q&A section. We have a couple of minutes before we'll head on to the next presenter. see a hand raised, but no question yet. So maybe I'll jump in and ask one. So this was for a few offshore wind parks in Europe, I take it?
Yes, yes, this is deployed in the UK. So Gwinty Real Flats, Galloper wind farms, they're using this currently. This was originally deployed, and we've been working on this now for a few years, but it's been in production for over 4 years.
Okay. Mm-hmm. And now I see some questions have popped in. I don't know if you can see those, Chris, as well. Can you show the integration diagram again, please?
Sure.
And what was the biggest challenge, handling data or handling the needs of different end users?
Yeah, I think regarding the biggest challenges here, the integration is always a bit of a challenge, getting access to data. One of the nice features of the platform is we can go out and actually connect to some of these root data sources. So that's nice, but it depends on the structure sometimes of the organization and its IT policies and rules. So getting access to production systems can be quite a challenge. And so that's much more of an internal politics. The platform itself can be deployed both on-prem and in cloud. So we can actually take the platform to the infrastructure where this is running, and that can actually help us sort of work around some of these potential networking challenges or firewall challenges that we may have. So that's a nice feature of the platform, is this ability to sort of reside where it needs to. And we've deployed, both in bare metal, in AWS, in Microsoft Azure. We can actually stand up the platform in any of those environments and run it.
All right, that's good to know. It's really flexible. So with that, it's time to move on to the next session. Chris, thank you very much. Really interesting. And I hope you can connect with and do a little bit of networking with the folks in the audience here. Thanks again for presenting.
Great. Thank you. Have a good afternoon, everyone.
Thanks a lot. Take care.